Okay, before we continue with our polynomial long division, because we're going to do one really large one right now just to finish off long division of polynomials. Just a quick little update. At the beginning of this series, I mentioned that I was going to grow the beard again. And as of October 1st, I decided to kick that into gear. So I'm going to be bearded chycho again, and instead of a clean cut chycho. So you're slowly going to see beard growing. Couple things before we start off on the long polynomial long division, right? I already mentioned that you have to put your terms in descending order, right? So if you have x to the power 4, that has to go first, and then x to the power 3, 2, 1, 0, or your constant, right? So all the x's, all your terms have to be in descending order, both for your product, your divisor, and your dividend, and your divisor, okay? So all your terms have to be in descending order. Another thing that you have to keep in mind, which goes back to series 2 really, where we talked about, adding like terms, right? If you have x to the power of 2, you can't add that to x to the power of 3. And this comes, this is really important when you're doing long division of polynomials, because sometimes you're missing terms. For example, you could get a polynomial where you have x to the power of 4 and then x to the power of 2. So you're missing your x to the power of 3. What happens is you might not have your terms lining up with the proper order. One thing you can do is just keep in mind that you can't add like terms, so the highest order goes first when you're adding it. The other thing you can do, which is what we're going to do, is put a place marker for the terms that are missing. And the place marker would just be 0 x to the power of whatever that is missing. The reason we're going to do this is because it comes in really handy with synthetic division. Synthetic division, you can do it without place markers, and we will talk about that. But it comes super handy for synthetic division, and we're going to do it for polynomial long division as well, okay? So we're going to put place markers for any terms that we're missing when we're putting them in descending order, okay? So for example, if we have the following, now this isn't the one that we're going to complete, okay? This is just to show you how you place the place marker, or put in the place marker, okay? So if we had the following long division that we had to do. (12x to the power 4 minus 5x squared plus 5 divided by 3x squared plus 2x minus 1. Okay, so they ask you to do that long division, right? So you're going to set it up in your long division format. And again, you're going to look for, what do you multiply 3x squared by to give you 12x to the power of 4? Well, that's just going to be 4x squared, right? So you're going to put that thing up there. So we multiply 3x squared by 4x squared, and we're going to get 12x to the power of 4. Now, for our dividend here, we didn't have the x cubed term, and we didn't have the x term, right? We're missing the x cubed term, and we're missing the x term. So what we did when we laid it out here, we put in 0x cubed, and we put in 0x here, and those are our place markers. That way we don't make a mistake of adding 8x cubed with negative 5x squared, right? Because if we didn't put those place markers there, this guy would be here and the 5 would be here, and we might make a mistake of doing that. Okay, so what we do, we put place markers there, that way everything lines up with descending orders. Now, if your first term in your numerator in the top here was a really high order, let's say it was x to the power of 27 and the next one at x to the power of 12, you're not going to sit there and put zeros, place markers for all the descending orders going down, right? All you're going to do is make a mental note that, from series 2, you already know that you can only add like terms, right? So you have to, keep in mind that you cannot add terms that don't have the same power. You can only add like terms, and you would forget about putting the place markers in, and just keep that in mind. And when you're doing your subtraction or addition, what you would do is just make sure you're adding like terms, right? right now, and the odds are you're not going to get too many questions, or you're not going to deal with too many polynomials where you have, x to the power of 27 and x to the power of 11 or something like this, right? You're not going to be missing too many terms between your terms, right? So what we do initially right now, just to get the process going, so we learn how to do it, and then later on for more complex polynomials we can just keep a mental note that you can only add like terms. So for these types of polynomials, all we do, questions that are low power, all we do, we put place markers here. Okay, so what we can do right now is we put the place markers in, multiply the whole thing out, and if you had anything missing in your divisor as well, right, in your denominator, you would also put place markers in the denominator as well, right? So what we do is multiply the 4x squared by, this guy, this guy, this guy. We get this term here, change all the signs and add them. So when you change all the signs and add your terms together, your first terms just kill each other. This one added together, 0x cubed is just 0, right? So all you're doing is just taking negative x cubed and just bringing it down, right? The other term, you add, negative 5x squared plus 4x squared is just going to be negative x squared. And what I do, as soon as I finish that, I bring all the terms down, okay? Over on this side, I bring everything down. That way, you don't have to continuously look up. Right? So again, what your question you're going to be asking yourself is, what are you going to multiply 3x squared by to give you negative x cubed? Okay. Now these 3 and 8 don't go together very evenly, right? And some people have a problem with this. So one thing you got to keep in mind is you can always get fractions up here. And we're basically going to stop doing this right now, but what I'm going to show you is how to figure out what you multiply 3x squared by to give you negative x cubed, okay? And this is the way you should, you should be really thinking about it, right? So what you're asking yourself is, what? The box is what? What are you going to multiply 3x squared by to give you negative 8x cubed? So all you do to figure out what goes inside the box is divide both sides of the equation by 3x squared. And your result is going to go there, right? Negative 8x cubed divided by 3x squared. The x squared reduces the x cubed down to x. So just kills the power in the 3 to 1. And these guys you can't reduce anymore, so it just stays negative 8 on top and 3 in the bottom. So what goes up top is going to be negative 8x divided by 3. So what you can do is figure out what you multiply 3x squared by to give you negative 8x cubed, and you just put that thing there just by doing, you wouldn't do this exactly at the bottom of, your long division format. You would take this and do it on the side, right? That way you leave enough, you're leaving your workspace empty so you can continue your work. So that's how you figure out if you have fractions, if you have things that don't multiply evenly together. That's how you figure out, what you're going to multiply them by to give you your, terms that you need to be able to eliminate your first term in, whatever the process is when you're doing the long division, okay? Now, let's, go find a bigger space and do a large polynomial long division, and we're going to write out the division statement, and we're also going to look at it graphically to show what it looks like graphically, what it means graphically when you're writing out the division statement, which is just basically taking one function, multiplying by another function, and then adding another function to give you your, numerator, your original function, or whatever you're starting with in here, okay?